Hey guys, welcome back to the shop for part 2 of the C5 Corvette rear driver side diff cover leak repair. Let's just jump right back in where we left off in part 1 now.
Toys for life.
Let's go ahead and drive this in using a seal installer. Be careful so that you apply pressure evenly and make sure it goes in straight. Keep an eye on that as you're pounding it in, and it will go in flush, and the next thing you know it'll be done and look exactly like it should. Go ahead and get your dental pick out and remove the O-ring from the diff cover. Switching gears back to the differential housing, make sure you get all the oil out of there, especially the oil at the bottom. You don't want that seeping down and compromising your new anaerobic seal. We're also going to remove that magnet, take it to the bench and clean all the fine iron type particles off of it. Luckily there was no big chunks of anything. So here is the clean case, and I can't stress enough, this has to be absolutely oil free around the entire flange, and make sure there is no oil in the bottom that's going to run out and compromise that seal. Here's the clean magnet. Go ahead and install the magnet back into the case in the same orientation that it was originally. We're going to add a little bit of grease to the bearings that are inside the diff cover so that the first mile down the road it has proper lubrication. And now we have the diff taped up so that we can spray the surface prep onto the flange. Let's make sure we clean that flange one more time with solvent to make sure it's 100% grease and oil free. Now we'll get our surface prep out, shake it a little bit, and apply a light, even coat around the entire flange. This is the catalyst that the anaerobic sealer needs to properly cure when everything is tightened down, when there's no more oxygen present. Next, go ahead and get out the new O-ring, and we'll install that onto the diff cover. Made in Taiwan, of course. And now we'll break out the anaerobic gasket sealer. We're going to lay a 3mm wide bead around the entire flange, not on the same surface as the O-ring, but on the flange part that clamps to the differential case. What we're trying to do here is add a second layer of defense against differential fluid from the differential coming out and seeping through this cover. The O-ring should be sufficient, but for some reason, especially on the driver's side, oil tends to get past, and that's why GM has specified to add an anaerobic sealer to help ensure against any oil leaks. Let's take a moment to talk about this sealer we're using. Per this document from General Motors, and this is the official GM procedure for repairing this diff cover leak, they specify the very expensive GM product 1052942. Keep that number in memory for just a moment. Now, you don't really think GM makes this product themselves. My guess is they probably buy it from Permatex. And look, here is the Permatex OEM chart, and it clearly shows the 1052942 being an equivalent to the Permatex anaerobic gasket maker. So we're good to go, right? Well, not so quick. If you look a little deeper on the anaerobic gasket maker materials, it says here specifically it's for use on aluminum, but there's some question as to whether or not that's pure aluminum or not. And if you look down here further, it talks about aluminum being an inactive metal. And for inactive metals, you need to use the surface prep, which contains some iron and or copper ions or something like that, which is necessary to be the proper catalyst to get the anaerobic sealer to harden. So I'm going to spend the extra $20 on the surface prep to make sure that this material hardens. Now, before we go ahead and install the cover, make sure your bolts are nice and clean. Don't put some greasy, grimy bolts back in. For the cover, this is the moment of truth. Get situated comfortably where you can manipulate each arm. Slowly move the cover into position. If for any reason you hit the anaerobic sealer on anything, take and clean off that part and redo it. Otherwise, continue to proceed to move it into position. Align it with the, there's a dowel pin sticking out of the transmission. Make sure that's aligned properly, and carefully move the cover in towards the differential because you don't want to have to twist it at all. and then slide it in as far as you can get it by hand. And then what we're going to do is we're going to take our clean hardware and install all 6 of them nice and finger tight around the perimeter. Then we're going to grab a ratchet wrench and slowly just give each one a couple of turns and move around the perimeter, watching to make sure the cover's being sucked in evenly and that it's correctly going onto the dowel pin. Continue working your way around until you get them all slightly hand snug with a 1/4 inch ratchet wrench. Then, of course, we're going to move to the torque wrench, where we'll torque each bolt down to 20 foot-pounds and make sure you hit them all in a circular pattern. Now, if you did everything correctly, you should see a continuous but not excessive amount of anaerobic sealer seeping out from the entire perimeter of the diff cover. Guys, here's a little science experiment that might help prevent you from freaking out if you're not used to working with anaerobic sealant and its unique characteristics. Imagine if these 2 pieces of aluminum represent the diff housing and the diff cover, and we're going to bond these together. So we'll go ahead and spray them like we did the cover with the surface prep. And then we're going to let that sit for about 3 minutes per the instructions on the can. 3 minutes has elapsed. We're going to go ahead and apply the anaerobic sealant like we did to the diff cover. Then this other piece of aluminum will represent the cover going on to the diff housing. We'll put that in place. Now we're going to bolt it down, and to simulate that, I'm just going to lock it in this vise. And I'm going to go ahead and leave this until tomorrow. All right, 1 full day has elapsed. We're going to go ahead and pull this out of the vise, basically unbolting it, if you will. And I'm going to set it down and take a look at this. If you're not familiar with anaerobic sealant, the fact that I can just simply wipe the sealant with my hands and it is the same as it was a day ago is kind of disturbing. It makes you wonder why it didn't harden. But once you wipe all this off, if you go ahead and take a screwdriver and pry this apart to separate them, you'll find that where it was clamped together, that's why they call it anaerobic, without oxygen. So without oxygen, with the aluminum and then also the iron and copper ions or whatnot from that spray, it actually causes it to harden, and that's what gives you the seal that you're looking for. So if you're not familiar with anaerobic compound, hopefully this might save you from a little bit of high blood pressure. Next, I'm going to go ahead and remount the vibration dampener. I like to use a little bit of blue Loctite on these bolts, and using a torque wrench, we'll snug these up to 18 foot-pounds. Next, I went ahead and reinstalled the driver's side portion of the catback. Go ahead and use a new gasket, and using a couple of wrenches, snug these up. And to make sure everything is symmetrical, go ahead and take a measurement to make sure that things look right from behind. Next, let's go ahead and clean up the axle. I'm going to use a little screwdriver to clean the splines because you don't want any gunk in there that you don't need. Clean the CV joint, and then apply a little bit of light grease to the portion that rides on the seal. Next, we'll reinstall the axle, carefully line it up with the splines, and then make sure it gets snapped into place inside the differential. Then we're going to go ahead and line the splines up with the knuckle and carefully get the splines so they come through the knuckle/wheel bearing assembly so that you can ultimately get a nut back on. Next, let's go ahead and reattach the rear upper A-arm. I like to use a little blue Loctite on these bolts. Go ahead and reinstall them by hand. I always start bolts by hand. And then we're going to go ahead and cinch them down with the air ratchet. And finally, we'll break out the torque wrench and go to 81 pound-feet of torque. Guys, putting together videos like this take a fair bit of time and energy. If you're getting something out of this video, please consider hitting the thumbs up, leaving a comment, and hitting that subscribe button. Thank you. Next, reattach the load sensor arm to the arm. And finally, the emergency brake cable and bracket assembly to the knuckle. Reinstall the bolts by hand, and then cinch them up. Then go ahead and reattach the cable to the little lever for the emergency brake and the connector for the wheel speed sensor. And now's a good time to torque the drain plug to 26 pound-feet of torque. Next, let's go ahead and reattach the tie rod to the knuckle. Now this is kind of an interesting deal here. The way this works is I'll hand cinch down the nut, and then you're going to need to hold the stud with an Allen wrench while you tighten it down by hand to say like 10 foot-pounds, not much, just till you kind of feel the stud lock into the knuckle. Then you need to torque it down to 15 foot-pounds, which is not much at all. Then I like to mark the stud so I know if it's rotated or not, install the torque angle meter, and then once I've got that set up properly, we'll use a wrench to turn it 160 degrees. Then remove the torque angle meter, make sure the mark you made on the stud hasn't moved, and then as one final kind of dummy check, you check it at 33 foot-pounds, and if you did everything right, you should hit that torque easy. Next, let's go ahead and reinstall the caliper, but first we'll clean the rotor with some wax and grease remover in case it became contaminated at some point during the project. Then we'll take the caliper off of our temporary hanger, slide it over the rotor, and install the 2 bolts attaching the caliper to the knuckle. Then, as always, go ahead and get your breaker bar out, and we're going to tighten both of these bolts to 125 pound-feet each. Next, let's move on to the axle nut, and as always, use a new one every time you install it onto the axle. And we're going to have an assistant hold the pedal so that the rotor won't turn, and we'll go ahead and torque this down to 118 foot-pounds. Next, let's go ahead and refill the differential, starting out with the 4 ounces of additive, which is needed to help the limited slip function properly without any noise. And then we'll go ahead and add, I think it's around 1.7 quarts of Mobil 1 7590 gear lube, and just keep adding it slowly until you notice it starts running out of the fill plug hole. At that point, it's full and you can go ahead and snug up the drain plug bolt. And finally, anytime I see wheel studs that look dry, if I know the vehicle's being stored inside, I'll put a little bit of oil on the studs. If I know the vehicle's going to be outside during Minnesota winters, that sort of thing, I'll put a little bit of grease on the studs. Go ahead and reinstall the wheel, all of the lug nuts by hand, and then we're going to torque them down. And I like to do them in a cross pattern. I start with 50 foot-pounds, and then I work my way up to 100 foot-pounds. Now we need to take it for a good long test drive so we can get things thoroughly warmed up and make sure it's no longer leaking. Guys, I got back from about a 10-minute test drive. I went in the house and had some dinner and came out about an hour later, crawled underneath, and things were oil-free. One more project taken care of. Guys, if you liked the video, please hit the thumbs up. If you haven't already, consider subscribing. And as always, thanks for watching.